Okay, so I think it's a really good idea to just make a mark on your part where you plan the chuck jaws to be. Um, I see a lot of students that get in trouble because they put a part in the chuck and they start to either pull it out of the chuck or push it back into the chuck, and then they leave the chuck wrench in the chuck, and we know that's a safety violation. So if you make a mark before you put it in the chuck, we can avoid that. Um, Take a look here. Getting the indicator in position. I'm going to spin the chuck around. I'm looking for the lowest reading. So when it's the furthest counterclockwise, and I line it up to a jaw, and then I zero the readout, I'm just giving it a little bit of extra tension to make sure that the part's not too loose in the chuck. Now I'm going to go 180 degrees of rotation, and I see about 8 thousandths worth of indicator movement. So I'm moving the dial to the 4 position, because half of 8 is 4. And then I know that if I tighten it to 0, that, well, as you can see, it's pretty much true. So uh, again, what I did is I found the lowest reading, made that my 0, and I went to the opposite jaw, and whatever that number is, divide that by 2, and that is your target. And since this is a round part, the other 2 jaws just need to be evened up. So we dialed that part in pretty quick. The chuck was also pretty close because I had dialed in a part before this, but the footage didn't turn out, so I had to redo it. Uh, Setting up my tool here. This is nothing fancy. We want to keep our overhangs to the minimum, as stubby as possible, but we also need to be able to do all of our operations. So you could look at this setup, and if it was for an industrial part, talking about making money in a shop, I would probably have a stubbier setup because I'm going to be taking a heavier cut. But in this learning environment, we're taking efficient cuts, but we're not getting after it. So setting my tool height, I'll show you a few different ways to find the center line height. This is probably one of the easiest. I've just brought a center that's located in the tailstock up close to my tool. Don't run into your tool. And then I'm just kind of going back and forth. I actually usually miss. It seems like I almost always err a little bit low. I have calculated the RPMs, and I have positioned my tool so I can take a facing cut and get a clean end on my part. I just want to remind you again to use 2 hands when you're operating the cross slide. You will get a much better finish. And I calculate the RPMs off of the outside diameter of the part. That's a good, safe thing to do. But you will see at certain times throughout your time in classes, we will sometimes go a little bit faster and a little bit slower. So right there, my tool tip was too low, so I had a very small knob. So I stopped it, adjusted the tool height. I still wasn't happy with it. So here I am adjusting it some more. With these quick switch tool changers, once I get my height set, then I can take that tool in and out, and it's not a big deal. So take your time, get your stuff right. It's going to help your finishes. It's going to help your tool life. It has to be correct. And then all I did is I just got rid of the little knob. I didn't bother to recut the entire face. I could have, but I knew I didn't need to because I'm about to center drill the part. So I don't think I actually calculate the RPM on film, but it's just your standard speeds and feeds formula. So I'd be doing 400. That would be our surface speed divided by the tip diameter of that center drill. And I usually just tell students, if you go around 1,000, you're going to be okay. The biggest concern is if you're going too slow, you will break off the very, very small tip of the center drill. So make sure that you don't do that. And unfortunately, pretty much everybody has to do that at least once. So if that happens, just come get me. I'll give you a hand. We'll get the broken off tip out of the end of the part, because you never want to try to center drill into a broken off center drill, because then you'll just have two broken center drills. Okay, so I turn the machine off. I'm gonna only loosen 2 jaws here, and I'm gonna keep track of which 2 jaws I loosen, because when I put my part back in, if I re-snug those first, it's gonna be very close to dialed in. I'm just showing you the end of the part. You can see that that is deep enough that the 60-degree included angle was present. You have to center drill your part till you get that 60-degree included angle. I'm looking at the print. I'm determining how long the turned section of the part's supposed to be. Oh, actually, the instructions say to chuck it with a 1/4 inch of material in the chuck. So that's actually what I was doing. I was making a mark at a 1/4 inch. And now I'm going to tighten the top jaw and then the jaw that's closest to my wrist. And we will see how much or how little run out that we have just by keeping track of which jaws we loosen, which jaws we tighten. Don't forget to bring the center up to the part. The center will lightly, see, I'm pulling the part to meet the center because the part was, a little bit down. Lightly blowing off the cross slide so I don't have my indicator sitting on a bunch of chips. So now I'm going to spin it around and I'm looking for the lowest reading. That's the furthest counterclockwise. Let me shake you up a little bit, get positioned here. This is my first time using this GoPro camera. I really like it. I filmed it in a goofy resolution, so you have black bars on the side of your screen. But you can see here, the part is pretty close. I mean, there's 3 jaw chucks that don't even get that close. So that was my furthest counterclockwise. So at 180 degrees, looks like, 4 thousandths. So I just moved. I knew I could get enough squeeze to actually just get half of that out. And then I go 180 and see what the other jaw's up to. So they're looking pretty even, so I'm probably could have just zeroed it, but instead I said, what the heck, I'm just going to turn the handle until I get to that 2000s marking. But there I actually zeroed it. And so you can see, I almost have a dialed in part because I kept track of my jaws. How accurate should you dial in your part? I always say just go to within 1,000ths because you can get there with very little effort. And there are times where parts don't have to be dialed in that close. But if you're not certain, just dial it in to within 1,000ths, and normally you're going to be just fine. If you're wondering, why do we dial in parts? If you think about a rotating mass, a part that rotates, and I'm not talking about when it's in the lathe, I mean when it's in use out in the world. If it's not dialed in, then you have run out, and well, that's just a recipe for early bearing failure if you have a rotating part. I'm marking the length that the part will be, and I'm giving myself a line to where I should stop the cut. I could have also used layout die and went into the surface plate, but why not save some time and just make a quick mark with a Sharpie? If it's not a critical mark or layout line, then don't use up extra shop time. This is going to be the stuff that kind of, it's the difference between a good machinist and a new machinist. Here we are, 1-inch diameter, 750 is what my cut size is going to be. So that's a 1/4 inch I'm going to remove. I decided I'm going to take that 1/4 inch of material in 4 passes at approximately a 1/16 per pass. So always make a plan as to what your cut sequence is going to look like, and then execute your plan. Here I am. I'm feeding it at a feed rate of 0.006, and my RPM is probably 400 or maybe 425. Who knows what the machine has as an option. But that 0.006 feed rate, it's definitely not fast, but I like it for all of my new students because I want you to have time to watch the cut take place. And then when you get more experienced, we can start to lean on the machine a little bit more and maybe rough at a higher rate. But for now, I just did what you're going to do. You can see my chips, they're coming off and they're silver. If you start a cut with high-speed steel cutting material and you see brown chips, or if you went all the way past brown and you're in blue, then it's time to back away and decrease the RPM, or go sharpen your tool a bit. So watch what I do here. When I get to my mark, notice I didn't back the tool away. I ran it towards the tailstock, and now I'm just going to go ahead. I'm going to take another 60 thousandths. I just give it a little quick swipe of oil and back to cutting. I'm going to speed this up in a second to a very, very fast rate, so we don't have to sit here forever. But you put too much oil on your part if you start to make a large cloud in the shop. So just a little bit. I want to have a film of oil for my cutting tool against the part, and that's going to help your finishes and your tool life. Now I stopped, and then I hand feed to the shoulder. Stop ahead of the shoulder. You never want to try to stop at the shoulder. So I do a quick check. I took 2 passes. I probably could have taken 3, but I want to see I'm at 0.880. So everything is matching up. That's where I figured I would be, is 875. So I'm going to go ahead and take another cut here. I just dialed another 60. When you make your dials adjustments, stay on whole numbers, the big markings, the 10s or the 5s. Leave your hand on the lever that engaged your feet. When you're a brand new student, you don't want to take your hand off the feed lever and then bring it back and put it on the half nut, for example. So, this is 4 times speed. Your cut will take a lot longer, and it's kind of it's not boring, but when you're really experienced, it is kind of boring. So I'm noticing that I have a lot of fuzz. So I'm going to go ahead and just lightly sand that surface. I don't really want to change the size as much as just get the fuzzy rough finish away. So now my micrometer can get an accurate reading. We want to take our finish measurements with micrometers. When we're roughing it in, use your calipers, that's fine. But I'm getting a good reading here with the mic. I thought the camera would actually be able to pick up what that size is. Here I am, I'm doing the math for the camera. So 812 is where I was. 752 is the top of my limit tolerance. That gave me 60 thousandths left. So I'm going to go ahead, throw on some oil, and then I'm going to dial that cut and take it. Be confident with your measurements and take your cuts to get to your finished size. If I would have taken 30 and then taken 15 and then taken 7.5, all I do is I add time to my project. Know that you're doing the steps correctly and dial for the size you want. If you get something other than that, figure out what happened and then don't do that again in the future. But in the workplace, you have to be efficient. Chip just landed on my shoulder. You see me kind of try to blow it off. Um, that's why we always wear safety glasses. The chips hit the chuck jaws and they fly up. So watch what I do here. I get to the shoulder and I back away, and then I come back up, and I'm going to actually move the carriage and the cross slide and kind of break that edge. Now, I don't know when the appropriate time for students to start doing that would be, but maybe when it's that close to the truck, it's not the best time to learn how to do that. But big picture, now that edge no longer has a burr. It has a very small chamfer. And obviously I lightly sanded, and now I'm going to take a mic reading. You can't see it on camera, but I'll tell you, I think it was a .753 reading, which is fine because I'll just use a little more polishing, and I'll be at that 752 in just a matter of 10 seconds of polishing. It's not a big deal, and I'll have a beautiful finish. I'm going to go ahead, I'm going to throw some bluing on the part, and I'm going to locate the shoulder. And I'm doing it in the lathe because, well, I don't want to take the part out, walk across the shop, go to the inspection room, scribe a line, bring it back, dial it in. That's a lot of time. So I'm just going to throw down a towel and put on some bluing. And I don't turn on the lathe while the bluing is wet. People do it all the time. Please don't do that. And then also don't blow the wet bluing and blow it all across the machine. So I'm just using calipers here. I opened really close to 5 inches, and then yeah, there I am. I lightly scribe the part. Now, would I do this with a $130 pair of Mitutoyo digital calipers? Probably not. But if I have a $30 pair of calipers, I know $30 it's money, but I'm not scratching the part. I'm trying to just scratch the bluing. And by the way, that bluing cup, it's really thin, or it's not dark. I don't know what the deal is with it, but normally the scribe line shows up better. But on camera you can't see it, but in real life I could see the scribe line very well. And that's pretty much going to wrap up this part 1. Part 2, I'm going to cut that next size, but I immediately return the center. You cannot afford to forget the part will come out of the chuck if you try to cut it without the center. So that'll wrap this up, and we'll talk more on part 2.